Hello everybody. In this lesson we will study about arithmetic progression, an introduction to arithmetic progression, wherein we will see what arithmetic progression is, what are some of the terms that are used while working on arithmetic progression. Welcome to the lesson. In order to understand arithmetic progression, let us consider few examples. Consider this list of numbers 1, 2, 3, 4 and so on. What do you observe? We observe that each term is one more than the term preceding it. 2 is one more than 1. 3 is one more than 2. 4 is one more than 3 and so on. So we can predict what will be the next term. It's going to be 5. One more than 4. So in this series of numbers, each term is one more than the term preceding it. Let's take another example. Consider this list of numbers now. 100, 70, 40, 10 and so on. What do you observe in this list? We see that each term is 30 less than the term preceding it. 70 is 30 less than 100. 40 is 30 less than 70. 10 is 30 less than 40. So can you predict what will be the next term? It will be 30 less than 10. That means it's going to be minus 20. So each term in this series is 30 less than the term preceding it. Great. Let's consider a few more. Let's consider this series now. -3, -2, -1, 0 and so on. What do you observe in this? We observe that each term is obtained by adding 1 to the term preceding it. -3 plus 1 will be -2. And -2 plus 1 will be -1 and -1 plus 1 will be 0. Can you predict what is going to be the next term? 0 plus 1 is going to be 1. So each term over here is obtained by adding 1 to the term preceding it. So what is an arithmetic progression then? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So when you add a fixed number to the preceding term, those series of numbers are called arithmetic progressions. And the fixed number is called the common difference of the arithmetic progression. And this common difference, this fixed number, can either be a positive number, it can be a negative number, or it can even be a 0. So now we know what arithmetic progression is. All the series of numbers that we saw earlier, are they in arithmetic progression? Yes, because every term was added by a fixed number to the preceding term, except for the first term. So all the series, all the numbers which we saw, the 3 examples, they were in arithmetic progression. Let us look at this list of numbers. Let us denote the first term as A1, the second term as A2, the third term as A3, the fourth term as A4 and so on. So the first term over here is A1. Now, the second term, that is 70, minus the previous term, 100, is -30. This is the fixed number that is being added to the preceding term. So this is called the common difference. Let us denote it by D. This is called common difference, CD, if we can write it that way. And now observe 40 minus 70 is also -30. it is same as the common difference D. And 10 minus 40 is negative 30. So, it is same as the common difference D. So, common difference remains the same throughout any two terms. A term and its previous term, the difference between them, the common difference will remain the same in an arithmetic progression. So, what are the two things that we need to know to form an arithmetic progression? We need to know the first term and we need to know the common difference. Then we will be able to generate further terms for the arithmetic progression. In general, we can write an arithmetic progression as A1, A2, A3, A4 and so on. And the common difference D is given by A2 minus A1, or it will be same as A3 minus A2, or it will be same as A4 minus A3. You don't have to find the common difference for every pair of terms. You can just find for the first and the second, and it will remain the same throughout. So, we know what is an arithmetic progression, we know what is the general form of the arithmetic progression, and let's try to solve a few examples. So, if we know the first term A and we know that the common difference is D, can we predict what will be the second term? It's going to be A plus D. What will be the third term? It's going to be A plus D, which is going to be A plus 2D. What is going to be the fourth term? It's going to be A plus 2D plus D, which is going to be A plus 3D, and so on. So, this is called the general form of the arithmetic progression. Let's consider this example. The heights in centimeters of some students of a school standing in a queue in the morning assembly are 147, 148, 149 and so on up to 157. Now, is this an arithmetic progression? Yes, because what is 148 minus 147? It's 1. What is 149 minus 148? 1. So, the common difference is the same throughout. So, this is an arithmetic progression. What is the first term over here? It is A1, 147. And this is the last term over here. Let us label that as AN, the nth term. So, we know the first term and we also know the last term. Such an arithmetic progression where we know the last term also is called a finite arithmetic progression. What about this example? The cash prizes given by a school to the toppers of classes 1 to 12 are respectively 200, 250, 300, 350 and so on up to 750. Does this form an arithmetic progression? Yes, because 250 minus 200, 50, 300 minus 250 is 50, 350 minus 300 is 50. So, the common difference D is the same throughout. So, this is an arithmetic progression. Because we also know the last term, that means the series ends, it is called finite arithmetic progression. So, we know what an arithmetic progression is by now. Let's try this problem. For the arithmetic progression 3 over 2, half, negative 1 over 2, negative 3 over 2, write the first term A and the common difference D. Can you try it out? The question already says that it is an arithmetic progression. So, the common difference has to be constant throughout. So, what is the first term A over here? It's going to be 3 over 2. And what is the common difference d over here? It is half minus 3 over 2, which is going to be negative 1. So, we know A and we know D. We have answered the question. Great. Which of the following list of numbers does form an arithmetic progression? If they form an arithmetic progression, write the next two terms. So, let's look at this. 4, 10, 16, 22. Does this form an arithmetic progression? Let's check it out. 10 minus 4 is 6. 16 minus 10 is 6. 22 minus 16 is also 6. That means the common difference remains the same throughout. So, this is an arithmetic progression. Can we predict what will be the next two terms? So, the next term is going to be 22 plus 6, which is 28. And the next term is going to be 28 plus 6, which is going to be 34. So, the next two terms are 28 and 34. So, this is how we figure out whether a series of numbers is an arithmetic progression and how we can predict the next two terms. What about this? Is this an arithmetic progression? Let us see. Minus 1 minus 1 is minus 2. Minus 3 minus 1 is going to be minus 2. Minus 5 minus 3 is again minus 2. So, the common difference is the same throughout, minus 2. So, this is an arithmetic progression. What will be the next two terms? It's going to be minus 5 plus the common difference minus 2, which is minus 7. And what will be the next term? Minus 7 plus the common difference minus 2, which is going to be minus 9. So, the next two terms will be minus 7 and minus 9. Is this an arithmetic sequence? Let's see whether the common difference is the same over here. 2 minus 2 is 4, and then minus 2 minus 2 is minus 4. The common difference is not the same. So, this is not an arithmetic progression, and we cannot find the other two terms because there is no common difference that is fixed, that is constant. So, we know how to figure out whether a series of numbers, whether a pattern is an arithmetic progression or it is not in the form of an arithmetic progression. Okay, in which of the following situations does the list of numbers involved make an arithmetic progression and why? So, let's check out this over here. The taxi fare after each kilometer when the fare is 15 rupees for the first kilometer and 8 rupees for each additional kilometer. So, for the first kilometer the taxi fare is 15. If you take one additional kilometer and 8 rupees is charged for it, so what will it become? It becomes 23 rupees. If you take another kilometer, to this 8 rupees is charged more. So, what will it become? It becomes 31. And if you take another kilometer, 8 rupees is charged more. So it becomes 39 and so on. So the series that we got is 15, 23, 31, 39 and so on. Is this an arithmetic progression? Yes, it is an arithmetic progression. What is the first term over here? It's 15. What is the common difference over here? It's 8. So this forms an arithmetic progression. What about this? Does this form an arithmetic progression? The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. If you just look at the question, how much air is removed at a time? 1/4 of what is left. Then the second time, 1/4 of what is left at the previous time. So we are not over here adding or subtracting 1/4, we are actually multiplying 1/4. So this, by the logic of the problem itself, it is multiplication of 1/4, not addition or subtraction. Therefore, it is not an arithmetic progression. Just by looking at the problem, we can understand this. What about this? The cost of digging a well after every meter of digging, when it costs 150 rupees for the first meter and rises by 50 rupees each subsequent meter. So for the first meter, the cost is 150 rupees. And if we dig further, 1 meter further, the cost is going to increase by 50 rupees. So it's going to become 200. If we dig another meter further, the cost is going to increase 50 rupees more from here. So it's going to be 250 and so on. So is this an arithmetic progression? Yes, it is an arithmetic progression. What is the first term over here? It's 150. And what is the common difference over here? It is 50 rupees. So this is an arithmetic progression. Let's do one problem of this type. Write first 4 terms of the arithmetic progression when the first term A and the common difference D are given as follows. A is 10 and D is also 10. So what will be the first term? It's going to be 10. The second term will be, since the common difference is 10, we add 10 to it. It's going to be 20. So what will be the third term? Add 10 to it. So it's going to become 30. The fourth term, add 10 to it, and it's going to become 40. So the series are 10, 20, 30 and 40. Great. With this, we have completed this lesson of understanding what is arithmetic progression and how we find the common difference of an arithmetic progression and how we can generate an arithmetic progression when we know the first term and its common difference. So great going. Keep practicing more problems on this. We will study further about arithmetic progression in the upcoming videos. Thank you for watching. Please share and subscribe. Thank you.